Hello everyone, in today's video of linked list we'll be implementing the insert operations. So there are in general three type of insert operation, that is insert at the beginning, insert at the middle, or we can call it insert after the node because you need to know after which node you'll be inserting, so it's going to be in the middle, right? And then you have, as you guessed it, insert at the end, right? So what we're going to do is we'll pick up each of these type of insertion and then we'll sort of formulate logic like how we're going to do that. After that we'll code this part out and sort of run them, okay? But before we move to the understanding the logic of these three operations, let's just write down the basic code. What I mean by the basic code is, let's write down our node, the node entity, right, that we'll be using. So as mentioned in my previous classes, we will be using the single linked list for performing all these operations. But in case you need help with other type of linked list also, then you can just ping me up and we'll make the video on that also, right? So let's start with the constructor def init self comma data. A single linked list only have two type of fields. The first one is data field, right, and the second one is the address field. For now let's call it next, okay? When you're formulating it, since it's a individual entity, it is supposed to point to null, and in that case none, in Python none means null, right? Yeah. And apart from this, let's also create a class for linked list, because what is linked list? It's a sort of combination of nodes only, right? So for linked list, let's only create the constructor, right? And just think a bit, what is going to be in the constructor of linked list? What does the linked list have apart from the nodes? Just think. So linked list only have one thing, and that is called the start pointer, right? Self.start. Start basically contains the address of the first node. That becomes your sort of the starting point, right? That is from where you start your traversal of a linked list. So yeah, but if it's a if it's a linked list that does not have any nodes, then it's supposed to be equal to none. So yeah, that is done. Perfect. Now let's go and let's start understanding each one of them. Okay, let's start with insert at the beginning. So in this type of insertion, what you do is you sort of replace your previous start node with the new node that you want to insert, right? In order to understand this, let me create a sample linked list, okay? We have a linked list that have three nodes, 2, 3, and 4. Since 4 is the last node, let's point it to null, 2, 3, and 4. Great. And this is basically your start, right? Perfect. Now what I want to do is I want to insert 1. I want to insert 1 in the beginning, so it becomes 1, 2, 3, 4, right? It makes sense. So what I'm going to do is now how should we create the logic of this? It's very simple. What I'm going to do is I'm going to make my 1 point to 2. Initially 1 is an individual node, and you see that when you initialize a node, its next is pointing to null, okay? So it is pointing to null. Now what I'm going to do is I'll make the change in this field. I'm going to make my next point to 2. How will I do that? From where will I get the address of 2? I will get it from start, right? Because 2 is the start node. So I have its address. So that is from where I will take the value of that field and I'll make it point to 1. Okay, just see my color. Yeah. So this will become, this way my 1 is now pointing to 2. And now what will I do is I will make my start point to the new node instead of 2. Right? Now what we have here is we have 1 that is pointing to 2. Remember, we have changed the address, and the rest of the node, they remain unaffected, right? They didn't even know what happened as of now. So this is basically how you create the logic of insertion at the beginning, right? Now remember, one thing I would like to emphasize on is that the order in which you perform the operation is essential. Why? Because let's say if instead of first pointing my 1 to 2, I pointed my start to 1, what would have happened, right? Think, there would have been no such connection. My start would have started pointing to 1, right? But now I sort of would have lost all my address to 2. I don't know how again will I get the address of 2. So basically this complete linked list is lost. start is pointing to 1, great, but what about 2, 3, 4? I don't even know the address, I don't know from where to begin, right? So that is why the order is important. So the first step that you want to do is you're going to make your 1 point to 2, and then you're going to make your start point to 1, right? Now let's try to code it up. Alright, let's create a function and let's call it insert at beginning. Okay, and what does this function need? It needs a self, and it needs the data, right? So first thing I'll be doing is creating my node, my new node that is going to be inserted at the beginning. And how to initialize this node? You call your node class that you've created earlier, and then you pass your data, right? Now you have your 1. Remember, I'm trying to sort of connect this with the diagram that we saw before. So this is now your 1. Okay, now remember the steps. What were the steps? You make your 1 point to 2, right? So how do you do that? Node dot next is equal to self dot start. Initially your start was pointing to 2, so now you say that, okay, whatever place your start was pointing to, make my 1 point to that place, make my new node point to that place. Okay, so you got your self dot start, great. Now what, you change the location of your start, right? Now you make it point to 1 instead of 2, so it becomes self dot start equals to node. Yep, I think that is done. This is your insert at the beginning. Perfect. Now let's validate this. So for that, let's create a linked list, right, and see if this is working as expected or not. Let me create our main function. Yeah, perfect. If name equals to main. Now let's create a linked list. A linked list is equal to my bad, not new, it's linked list, right? It doesn't need any values, it's done. And then you call linked list dot insert at beginning 3. Okay, and then you have ll dot insert at beginning 2. So when I sort of print this linked list, it should be printed in the order of 2 and then 3, right? By the way, I think I need to create a display function also, and this way we'll also be covering the traversal of the linked list. So let's do that. How do you print the linked list, right? uh, it's gonna be very simple. So let's see, let's create a function display. And what does this function need? It does not need anything. It just need you to call that. Okay, so dev display self create. Now you create a temporary node. This is the node that will sort of traverse from the start till the end. How do I identify the start? You have a start pointer. How do I identify the end? You know that at the end your address will be null. So yep, that is all that you need to know. You have self.head. Now you check your logic while temp. It will keep checking till the time temp is not null. So yeah, after that you simply go and you print your temp dot data. Perfect. And then you make your temp point to the next, right? So your temp was initially pointed to the first node, right? You printed its data and then you move to the next node, and till when do you keep moving? Till the time you don't encounter null. So I think that should do the trick. Now let's also display, let's call the display function, right? And let's see, is 2 and 3 getting printed, or are we getting some sort of error? So yeah, let's run it. I'm sorry, I'm getting some sort of error because I called it head instead of start. Yeah, that is a mistake that I generally do. Let me just run it again. So yeah, now we have 2, 3, but I don't think it's visible on the screen. Let me just run it again, my bad. Perfect. Now as you can see that the 2 is getting printed first, and then 3 is getting printed, right? Now those of you who might know advanced data structure, you might be able to connect this to stack, and yeah, it's true, this is how stacks are created, but that is the story of next day. So right, so let's start with our next function that is called insert after init. Yeah, so in order to explain this type of insertion, let me create a sample linked list, right? So you have 1, you have your 2, then you have your 3, and then you have your 5. Perfect. So what I'm going to do is I want to insert a fourth node, a node with a value of 4 after 3, right? So in this type of insertion, you need two things. You need basically the new node that you want to insert, and you need the previous node, basically the node after which you want to insert 4. So in this case, I have two things. Okay, let's be clear of what we have. I have 3 and I have 4. Perfect. So how exactly am I going to do this sort of insertion now? Very simple. It's very similar to the first insertion, right? Since I have 3, since I have the complete 3, I also have the value that the next fields of 3 stores, right? I have this value. So I'll copy this value and paste this here, due to the virtue of which 4 will start pointing to 5, right? And then what will I do is I will make my 3 point to 4. So this way this connection will break. 3 will point to 4 and 4 will point to 5. So it becomes sort of like this: 1 after 2, 2 after 3, 3 after 4, and your 4 after 5, right? Sort of a happy ending. Your 4 is successfully inserted, 3 start point to 4, 4 start pointing to 5, and basically 1, 2, and 5 sort of remain unaffected. They didn't even know what the hell happened here, right? So yeah, this was the insertion after node. Let's move to the coding part. Okay, so let's create a function. Let's call it insert after, and as mentioned, it needs three things. It needs your previous node, the node after which you want to insert it, and again it's need the data of the new node, right? We can create a new node here. So what is going to be the logic you want? First, let's create a new node. Your node, you call your node class, you provide the data, and then you have your new node. Done. Great. Now the first thing that you'll be doing is you're going to point your new node to the next of the previous node, right? You basically want your 4 to point to whatever your 3 was pointing to. Please try to connect with the previous diagram. So what will happen here is your node dot next is going to be equal to the previous node dot next. Great. Now we have created a connection between the current node and the next node. Great. Now what do is you make your previous node dot next get updated, but to what value? You want it to point to your new node. So yep, this was the logic of your insert after. However, there is an edge case. What if the previous node that I gave you, it doesn't exist? That can happen, so you sort of need to handle that case. So what can you do for that is, if you can simply check that if previous node is none, in that case you may just return, we can print something also and just return. So this is just an edge case that we're handling. Okay, so now let's validate this, and for that I'll be creating the same linked list that we saw in our previous example, right? So let me just copy this function, and what we'll be having 5, then we'll be having, no, not 4, we'll be having 3, 2, and 1. Yeah, one thing I think I made a mistake here. It should be not new node, it should be node. There is no such thing as new node, right? Great. Now what I'll do is I'll call my function insert after, and then I'll pass it. What do I need to pass it? I need to pass it basically the previous node, right? So that will become new ll dot start dot next dot next. Start is the first, then next, and this next, so it becomes 3, and then you pass it the value that you want to insert, right? Okay, my bad. So before I actually implement this function, before I call this function, let me just see what is the current linked list, right? So I'll just run this function. It should be 1, 2, 3, and 5. Yeah, it is 1, 2, 3, and 5. Perfect. Now what I want it to happen is 1, 2, 3, 4, 5. Let me put my function back and call my run console. So as you can see, it is now 1 2 3 4 5. So yep, our function works perfectly. And this brings us to our last function, that is insertion at the end. So insertion at the end can be sort of thought as a combination of the traversal function, the display function, and the insertion at the beginning part, right? So let me show it to you how. But for that, let me create a linked list. Okay, 1 2 and 3. Yeah, this should suffice, right? And this is where your start is pointing. I want to insert my 4 after 3 to make it 1 2 3 4, right? So what are you going to do this? Unlike your insert after function, in this case you only have your start pointer and your new node, right? So what we'll be doing is we will start from the start pointer and we will traverse it till we encounter the null, the same way that we used to do this in the display function, right? But we won't actually reach till null. We will be checking that is the next of the current node. I mean, I will be at 3 and I will check is the next, this is the next, right? Is the next of the current node equal to null? If it is null, it means that I've reached at the end. So once I've done that, what will I do? Right? My 4 is, I mean, my 4 is pointing to my 4, that is the individual node that I want to insert. It is its next is also pointing to null. So what will I do is I will simply make the next of my last node, basically the next of my 3, point it to 4, the new node. What will happen, let's for now call, so what will happen, the 3 dot next will become equal to 4, and we know that 4 dot next is already equal to null. So by default it becomes your last node and 3 starts pointing to 4, which in the end creates it a connected node 1 2 3 and 3 and 4. So this is your insertion at the end, right? So yeah, that was all for the insertion at the end, and let's move to the coding part. By the way, if you have any comments in any of the insertion technique that we have discussed, do pick me in the comment section. I'll try my best to help you, right? So yeah, so let's start with a function insert at end. You only have your what can we call it, data. You have your data, right? You create your node that you want to insert, node, you pass your data, and you are done. Now you create a node called last that is supposed to point to the last node. So yeah, self dot start, this is the node that will also be responsible for your traversal. So self dot start, and then you call your while function. And earlier you were just simply calling while and you were checking for temp, but this time what you'll do is while last dot next, right? You want to not exactly reach at the null, you want to stay one step forward, right? One step actually backwards. Yeah, so till the time this is happening, what do? You just keep saying last equal to last dot next. You're not supposed to print anything, so there's no need to call the print function. Last dot next, and once this loop ends, you know that you are at the last node. So what do? You say your last, remember what do you say, your 3.4 equals to 4. So last, my bad, last dot next is equal to your node, and voila, you are done. Yeah, right? You can simply close your function up. One edge case that I would like to point out that most of the people miss is that what if this was an empty node? What if that was the case? So in that case, you can't really start your traversal. This will actually give a null pointer exception. So what will you do? You, before creating your last, you actually check that is this is an empty, no, if this is an empty linked list. So how do you check that? Very simple. You call your if self dot start is equal to, sorry, my bad, I can just check it like this. If is none, it means that your start is none, it means your linked list is empty. If that is the case, how about I just make my head point to this, not my head, I just make my start point to this node, because that is insertion at the end, right? To data, not to data, to node. And let me just return, this is, oh yeah, this is edge case when base, okay, what am I doing, I'm so sorry. This is your edge case when LL is empty. Perfect. Now let's validate this. We have your insertion at the end. So how are we going to do that? Very simple. ll.insert at end, right? Let me call 1, and in the same manner, let me, where is this? Sorry for this. 1, 2, 3, and 4, right? It should be printing 1, 2, 3, 4 in the same exact order. This is those who are able to connect. This is an implementation of queue also. So yeah, let's run and let's see if it works or not. Great, we have 1, 2, 3, 4 printed, and yeah. So basically these were your 3 types of insertion. Insertion at the beginning, insertion after a node. You can implement sort of the same logic if you want to, create a function insert before a node, right? And then you have your insert at the end node. So yep, that was all for today's video of insertion. After that, we'll be continuing a series with the deletion and maybe other function like searching and all. Yeah, but remember, insertion is a very basic yet very important node part. So if you have any questions, feel free to ask them. And that was all for today. Thank you for watching this.